For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
All right, looks like we are live, guys. Thanks for your patience. I promise you this will be worth it. Guys, we got a lot of great shows for you in the coming week or two, I should say. So before we get into this, a couple of brief announcements. We're going to have Professor McQueen back on this Thursday. So typically we're here on Wednesdays with Professor McQueen. This week we're doing Thursday, 4 p.m. EST. We're going to be dismantling dating methods, going over the lines of evidence for accelerated nuclear decay. So that's going to be a lot of fun. On the 4th of February, we got Michael Ord, top flood researcher. He's going to be here giving us an awesome presentation on amazing evidence for the worldwide flood, the receding floodwater. So we're going to be discussing the various stages of a flood, followed by a question and answer. So please bring all your best questions. I am pumped for that. This Sunday, I'll be having a formal debate with, he goes by This Boy Draws. We're going to be debating naturalistic origins versus biblical creation. So there's also a few other discussions, interviews, and debates in the works, and I'll announce those when they are officially confirmed with dates and time. So I appreciate it. We've got a good audience already, guys. Thanks for being here. Today I've got TopDawg with me. We are going to be discussing the topic of ancestry. Does all life share a common ancestor? This is kind of the third discussion in a series of cordial dialogues with people of the opposing side, right? Me being the creationist and the guest typically being an evolutionist or naturalist. So if you've been enjoying this series of dialogues, check out my discussion with Luca on independent origins from a couple weeks ago. Just a few days ago, I had a rational empiricist on here where we discussed nested hierarchies. That was a great discussion. And tonight we got TopDawg Shadic here. I hope I said that right. So TopDawg, thanks for being here. Give a brief introduction, my good man. Let the audience know who you are, I know you've got a channel with some videos pertaining to this topic on the channel, as well as, I believe, a blog where you've been making some posts. So yeah, give us a brief introduction.
Well, I'm TopDawg Shadic, and I'm a rational human being and like to learn about science or the real world. And through videos, let's see the real world, because you can't do it yourself, and so I use videos. There's some of that stuff. I mean, you can do it yourself, some of it, but.
Awesome. Well, hey, listen, with enough information, adding mutations, maybe one day we will get a dog that can speak quite like you. So it's impressive. Enough novel information, enough mutations, that may be possible. Stupid Whore Energy says, "Who let the dogs out?" I'm guessing that's one of your favorite songs there, TopDawg.
A long time ago when it came out.
All right, so why don't we do this? You're the guest, and we're discussing the topic of ancestry. Is all life related through common ancestry? I think you had a video you wanted to share and just kind of go over what you believe are some of the most irrefutable lines of evidence for universal common ancestry. And then what we can do is we can take those one by one and just discuss them, run with them. We'll do this for about an hour, guys, because afterwards we're going to have a 3,000 subscriber after show party, open mic, in a couple hours from now. So that'll be fun. Anyways, let me share your screen, TopDawg. Make sure your audio's good to go as well. We'll play this video. Maybe just to avoid any copyright issues, like we were saying pre-show, make a couple comments briefly in between. Maybe every minute. It's about 4 minutes. So maybe at the 2-minute mark, make a couple comments, a few things up. And then once the video is done, we'll start talking about the content of it. So anyways, I'm going to mute myself so we can hear. And when you're ready to go, TopDawg, go ahead.
Well, this is a video from It's Okay to Be Smart. There it was no first human. Here we go.
This is me. I'm a human. These are my parents. They're clearly humans too. My grandfather, human. My great-grandfather and great-great-grandfather, humans without a doubt. But my grandfather, 185 million generations removed, not a human. He was a fish. So imagine you could take a picture of every ancestor down the line and put them in a big stack. Every father's fathers, 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 father. And well, that would be a very big stack with me at the top and my fishy forefather all the way down at the bottom. Maybe we should lay the stack down on its side. That would be a little safer. As we journey back in this stack, let's pull out a few snapshots from history. 1,000 generations back.
So it's a minute. So you think that's good for a few seconds now?
Sure. Yeah, I would just, okay, so I'm just writing a few things down as he speaks and as he makes his arguments. So yeah, keep it going. I've definitely got a few thoughts, but I'll save those until the end of the video. So keep going until about the 3-minute mark, and then pause it there for a second, then we'll keep going.
Okay.
Back, we're just a few inches in, and well, we find a human. 10,000 generations ago, just 2 steps further, and well, still human, but not like we recognize. 75,000 generations ago.
Oops, my audio's going bad for a second. Let's reboot it. It's normal.
That's 1.5 million years back, not a human. That's Homo erectus. Here we are just a few hundred steps back in our journey, 1.5 million generations ago. Well, this ancestor looks more like today's old world monkeys, but still a primate. 15 million generations ago, and this ancestor looks more like a tree rodent than a monkey. Let's jump all the way back to my 120 millionth great-grandparent. This is 12 kilometers back down the line. This is a decidedly non-human, non-primate, shrew-like mammal, but kind of cute. My 165 millionth great-grandparent is not even a mammal. It's a prehistoric lizard that predates even the dinosaurs. They've got their own photo album, their own stack that joins up with ours somewhere around here. In fact, every species has their own stack that branches off somewhere down the line. And here we are 185 million generations ago at our ancestral fish. You see the resemblance? So where along the stack was the first human? There wasn't one. Photo number 4,632, human. Photo number 79,221, well, that's Homo erectus. There's no single point where one became the other. Every photo that we pull from the stack looks pretty much like the photo on either side. Every generation is the same species as its parents and the same species as its children. Homo erectus had Homo erectus parents and Homo erectus kids. Our fishy ancestor, fishy fathers, and fishy children. You can never pinpoint the exact moment that a species came to be because it never did. It's just like how you used to be a baby and now you're older, but there was no single day when you went to bed young and woke up old, although sometimes it feels that way. There was
3 minutes.
All I'll say until it's done is this. It's an interesting video, and I'm writing down points, relevant points to what he's saying, and I think it's going to lead into a good discussion on this topic. So for the next minute, yeah, just let it go, and then once the video ends, end the screen share, and maybe take a minute or two, kind of summing up what your thoughts are of the video and how you believe this points to all life being related, and then we'll go specifically touching on the topic. Go ahead, TopDawg.
Okay.
Was no first human. It sounds like a paradox. It sounds like it breaks the whole theory of evolution, but it's really a key to truly understanding how evolution works. Evolution happens like a movie, with frames moving by both quickly and gradually, and we often can't see the change while it's occurring. Every time we find a fossil, it's a snapshot back in time, often with thousands of frames missing in between. We're forced to reconstruct the whole film. Life is what happens in between the snapshots. Instead of a nice, smooth road, this is a journey on stepping stones, and we give each one their own name. Stay curious. This journey was in...
Okay.
All right. Why don't you take a couple minutes or however long you need, 30 seconds, 20 seconds to kind of sum up your thoughts on the video and why you believe the content or the so-called lines of evidence presented in the video would fit far better with a model that suggests all life, banana plants, whales, pine trees, monkeys, man, are all related through common ancestry. Maybe if you want to just take a few seconds to sum that up.
Well, there's more than the video was talking about. It didn't talk about DNA or anything, so it just talked about how after the fact, the stuff that we write down or find and discover and stuff.
Right. So would you say that the DNA evidence, the DNA data backs that video up, corroborates the content in that video? Is that what you're saying?
Yeah.
Okay. Yeah, I apologize for interrupting there. Take as much time as you need, then I'm going to take a few minutes to give my comments on the video, screen share a couple things, and then we'll kind of go back and forth. So go ahead, TopDawg.
So the way that humans understand things, it seems like we need to have it segmented. So like the species and stuff. So because there's so many layers or so many descendants and stuff, and so many life forms, you can't name every single one. So probably is trillions and beyond. I mean, Googleplex maybe. I don't know the amount of life forms we have to consider, but and that would be known how we're related by our DNA and stuff. So I can't really think of what to say. I'm not very good at talking.
No, that's okay. That's okay. So I'll give a few thoughts. So right off the bat, he states that we can go back thousands and thousands and thousands of generations to our fish-like ancestor, right? Okay.
That was fossil record, I think, was the evidence of that we see past life forms.
Right.
That's
but by definition, he is appealing to thousands and thousands and thousands of generations. Yes, eventually you have to go back into the fossil record and make assumptions and inferences. But my point would be that we don't have any more than really a few hundred generations to go back to, because he pointed to Homo erectus, Homo neanderthalensis, and some of the other so-called hominids, right, that are found in the fossil record. He looked to Tiktaalik and a few other species known only by fossils. But the fact that we can only go back a few hundred generations based on the direct lines of evidence, which I would say are genetics, right? Genetics is what's inherited sperm and egg. Genetics tells us we only have a few hundred generations to work with. So when it comes to Neanderthals, when it comes to Erectus that he was pointing to, even Tiktaalik, okay, the existence of these, well, I would just say Neanderthal and Erectus are human variants, okay? Then when it comes to Tiktaalik, I would say the existence of these are better suited for a biblical base model. Now he did, the entire video was essentially, and correct me if I'm wrong, was essentially about the law of monophily, as in we cannot outgrow our ancestry, right? A eukaryote will never stop being a eukaryote, okay? A mammal will never stop being a mammal. A vertebrate will never stop being a vertebrate. It's descent with modification. According to evolution, you've got shared derived synapomorphies. So every generation, you're adding more traits. But that first generation, whatever you were, you never stop being. That's essentially what he's describing. Now, I would say this law of monophily, the fact that we cannot outgrow our ancestry, okay, that fits far better within a biblical model, because yes, what we see today, okay, let's say all the variants of the dog, okay, the canids, whether you look at all the different species or all the different dog breeds, you could trace those back, okay, to an original ancestor that would have been the originator of all these dogs. According to our model, you couldn't take that back to a single-celled like ancestor. No, you would take that back to a type of canid ancestor. Now, one thing I'll say, and then I'll let you give your thoughts. I'm going to screen share a couple of pictures here because I feel that when it comes to these classification systematics and looking at these traits, you can look at a number of traits, okay, and you can classify them any way you want, okay. And typically what we'll get when it comes to cladistics, taxonomy, phylogenetic systematics is we will get a nested hierarchy. So all of this does is demonstrates the existence of a hierarchy, but it doesn't actually explain why that hierarchy exists. Why are humans and chimpanzees more similar in terms of morphology, anatomy, physiology, and genetics than, say, a human and a banana, or a human and a fish, or even a human and a lemur, right? There is this hierarchy that we see in the biological world, okay? We see homologous patterns as well. Now, here's the problem, okay, is the inference the evolutionists make. Because according to the design model, okay, God created us in his image. Therefore, we should be able to get a sense for how God designed the biological world based on how we design things. And it just so turns out, I'm going to go through a few slides here, humans build in homologous patterns. Humans build transitional-like vehicles, right? For example, right here, the military has what's called an amphibious assault vehicle. This is a vehicle that blends the features of both a land vehicle and a vehicle built for the oceans. The perfect transition between these two environments that were designed this way, okay? And if we were to look at modes of transportation, you're going to have sedans that are a lot more similar to SUVs and trucks than sedans would be to bicycles or airplanes or boats, okay? You can bring in anything into your hierarchy, and that's exactly what you're going to see. The point is nested hierarchies are products of design. So once again, that's a line of evidence or observation that's agnostic, because I like this slide here. Okay, you've got the tree of life, okay, where everything can fit in somewhere, because we all have DNA, RNA, proteins that code for the morphology, that code for the anatomy of species. Okay, so you'll be able to, by definition, fit them somewhere when you're classifying animals, okay, kingdom, phylum, class, order, family, genus, species. This all originated from Linnaeus, who was a creationist, right? And he assumed creation, he assumed design, he assumed these hierarchies were there by function. Evolutionists, when you look to Aaron Ra, he has this phylogeny challenge. His phylogeny challenge is fallacious and a straw man, because to have such a challenge where he thinks there's going to be this straight barrier or line between, say, humans and all the rest of the biological world makes no sense, because that means you'd have humans here completely separated from the rest of the biological world. But how would that ever be possible when, in fact, we have DNA, RNA, protein that code for the morphology, anatomy, physiology, for example? Okay, so by definition, when we compare through genetic sequencing or compare the anatomy, the morphology, by definition, we will be closer to some creatures like the chimps, okay, and more distant to other creatures like a bacteria, like a fish. Okay, so this nested hierarchy is expected on both sides. So this phylogeny challenge would be a fallacious, a straw man. Here, we can do the same thing with tools. I mean, we classify tools all the time. You got 31 different types of wrenches, okay? And typically it's very easy, TopDawg. But what happens when you pull in fencing pliers, which is a multifunctional tool? I mean, it consists alone of wire cutter, a wire puller, staple pincher, okay, a general purpose hammer. It's designed in a way that incorporates a number of different tools. This is essentially a mosaic. So where do you categorize it, right? Where do you classify it? Is it more similar? Where do you stick it here? Do you put it here on the end? You know, would you put it here? Oh, okay. We put it right in here. And according to the evolutionists, it's the perfect transition. It would be like me making a prediction. Okay, so we've got 2-wheelers and 4-wheelers. Okay, I predict you're going to find a 3-wheeler out there somewhere. These are the types of predictions the evolutionists are making based on the fossil record. Oh, lo and behold, we find a 3-wheeler. So therefore, the 3-wheeler must be the intermediate between the 2-wheeler and the 4-wheeler, in the same way that this multifunctional tool must be some type of intermediate. No, this is just basic design. The way we design things, whether it's computer code, modes of transportation, tools in your tool shed, they all can be classified. Now, I don't think this fencing plier really cares where it goes in terms of classification, in the same way that a whale or a chimpanzee doesn't really care where we as humans, with our man-made classification schemes, decide to categorize these animals based on a number of different traits. Now, here's the last thing I'll say, though. Even though there is a hierarchy, and then I want you to give your thoughts. Even though there is a natural hierarchy, TopDawg, there are so many inconsistencies to the hierarchy when it comes to evolutionary theory and the phylogenetic tree, when it comes to things like convergent evolution, okay? Even though these two creatures look similar, they are completely different animals. One is a marine reptile, the other a marine mammal from a completely different time period. So these highly complex structures, okay, apparently evolved independently. It's hard enough to get a series of mutations to design new novelties, new structures, to explain phenotypic complexity, let alone do it multiple times. I mean, they say the eye independently evolved like 40, 50 times. Okay, not only that, you get contradictions in terms of what's called incomplete lineage sorting. That's why I specify, do you believe the DNA data corroborates the data from anatomy, morphology, for example, when it comes to these, when it comes to taxonomy? No, it turns out depending on what trait you look at, depending on what gene you look at, you get completely contradictory trees. Sometimes, depending on the gene you look at, you get the humans that are closer to the gorillas, or the human that's closer to the bonobo than the human that's closer to the chimpanzees. So it's inconsistency after inconsistency. And we could look to mosaic evolution, loss of traits evolution. So the point is, there is an nested hierarchy by rule, but these inconsistencies, the evolutionists have no way to explain them away other than post hoc, ad hoc reasoning. Go ahead, TopDawg. What are your thoughts on some of that? That would be, I guess, my intro as compared to your intro with the video and your few thoughts afterwards. So what are your thoughts on some of that?
Well, we have to go one at a time because I have to remember all that. So I have to go from the beginning again.
Yeah. If you want to just start at maybe the patterns that exist in nature, that's kind of where we started. Was the law of monophily combined with taxonomy, cladistics, looking at traits and classifying species according to characteristics. If you want, we can start there, or wherever you want to, and then we'll take it from there, TopDawg.
Well, I can't think of what's the first thing.
Okay,
I have to show this slide again, I guess.
Okay, since that video, okay, you believe was demonstrating universal common ancestry, okay? Tell me how you would explain the existence of convergent evolution, where you've got organisms not actually closely related, okay, not monophyletic, independently evolving similar traits, highly complex traits that we haven't seen evolve to begin with, like eyes. They say eyes evolved independently like 40 times, okay? And they're saying that this is independent based on adaptation to similar environments, ecological niches. So here's the point. anytime they invoke convergent evolution, they are admitting to a lack of uniqueness in their phylogenetic tree. So how would you explain, according to your model, not through post hoc ad hoc storytelling, but actually through empirically, how do you explain convergent evolution when it comes to the expected evolutionary nested hierarchy? Let's start there.
Shouldn't that be in our DNA? Where we could see where differences and where it was, how it was put in where it's in the DNA, I guess.
Well, have we
So
seen?
if it's different from a different spot and stuff, so then that's how we know it's not coming from the same ancestor. That's what I think. That's what makes sense.
See, so that's a good point. So when they look at gross anatomy, when they look at morphology, okay, you would then, let's take for an example the echolocation system in mammals. So you've got dolphins, whales, and bats. Okay, they all have the ability to echolocate. Now, based on gross anatomy, though, the whales and dolphins are actually closer to what? Cows and
Hippos, hippos,
land
and
mammals. But on the basis of their echolocation systems, or at a genetic level, like you're talking about, there's a protein called prestin. And based on molecular sequencing of the protein prestin, and based on their echolocation system, okay, when it comes to a hierarchy, you've got the whales and the dolphins nesting with the bats. So you got a contradiction when you look at a molecular level, like you're referring to. You got a contradiction when you look at the anatomy and the morphology.
So are the bats using their vocal cords to echolocate?
They're using, they're utilizing the same underlying protein and mechanical systems as the whales and dolphins, because the underlying protein, okay, that's involved with echolocation is virtually the same in bats, whales, and dolphins. Now, I'm going at the top of my head here, okay? So I'm 99% certain of this. And the protein prestin in your land mammals, okay, all your land mammals that the whales and dolphins based on gross anatomy would nest with and be classified with, their protein, the protein prestin, is nothing like the whale, dolphin, and bat protein. So yeah, the whole system, the underlying system is very similar in terms of how echolocation is accomplished. Now, I'm not here to trap you or anything. My whole point is, listen, there's a hierarchy, but there are inconsistencies. Here's the biggest problem, okay? Have we ever seen, TopDawg, have we ever seen the eye evolve? Have we ever observed something as complex as a wing evolved? Have you ever seen these structures that they say evolved numerous times independently throughout evolutionary history? Have we ever seen those actually evolve in real time?
Well, it takes little increments over a long period of time. The environment's changing, how those things happen.
Now,
it's what survives.
And here's the thing, though. Would you admit that structures such as wings and the ability to fly, or eyes and the ability to see, this, as you said, would take a lot of time and a lot of beneficial mutations?
I guess it's benefit now to us. We don't know how much, what it was in the past. I mean, we can kind of in the fossil record.
So here's what's funny is there are evolutionists who have said, if we were to rewind the clock backwards, because evolution for the most part is random, right? Random mutations, natural selection acting upon these random mutations resulting in random variation, genetic diversity, okay? They'll say if you rewind the clock back and you were to let evolutionary history play out again, it would be totally different. because it's random. There's no guiding force. There's no designer, essentially. So would you say that if we were to rewind the clock back and just let it happen again on its own, would it produce the exact same outcome that we see today in terms of organisms?
Not the exact same, but similar maybe. If the environment's enough, the right time and stuff, and it's whatever it's living in.
And here would be the problem is there's been some evolutionists who say, no, it'd be totally different because it's random. You're saying it would be similar. Okay. Are you saying... Go ahead.
Only similar if the environments were to happen. I mean, that doesn't happen. I mean, it's hard to explain. It only the microbes and stuff probably would be the... I mean, that's not... It's hard to get when you get more complex and stuff and more time, environments are changing and stuff. So it's too many factors. So, of course, it's going to be different. But I'm saying if they were the same enough, like bacteria or something, hasn't changed for a long time. So.
And that's the major problem. And that's the major problem is this, okay? In the fact that nobody disagrees with the microevolutionary changes that we see, okay? That just means, hey, listen, we're getting a change in allele frequencies, which are just gene variants. So we're essentially getting a change in the frequency of the expression of these different alleles or these different traits. Okay, general adaptation, the evolutionists and creationists would not dispute, would not disagree with. But the type of evolution that lacks evidence empirically is not the small scale variation. It's the major origin events of structural novelty, the major innovations, major new forms of life, major body plans, okay, novel information essentially. So here's the problem with convergent evolution is things like wings, where the function is oftentimes flight, or eyes, or echolocation systems, okay, and I can go on and on and on, okay. I've got a list of about 100 examples of convergent evolution. The evolutionists have to imply or assert that all of these novelties that are highly complex, okay, and the DNA, RNA, and protein that essentially encode for these structures and functions, that is highly complex. So they have to say that not only did this evolve once or twice or 3 times, in the case of the eye, 40 times. I mean, do you not see how much imagination that would take? I mean, do you really believe that the eye can evolve 40 different times simply based on environment, apparently? I mean, go ahead. What are your thoughts on that?
That's what we see in the real world. And the Earth is pretty big, and lots of different environments, lots of reasons to be changed so you can survive. You know? I mean, it's not that they had a reason to, but it's what did, and then here we are with the life.
See, but everything you just said is assuming universal common ancestry and then looking at what we see today, right? And that's why I explained microevolution, the microevolutionary variation that we see, adaptation. Okay, you can't take that and then extrapolate that single-celled like organisms evolved into man or into whales, or the eye evolved 40 different times. Now, the whole point of this is, listen, I've seen hundreds of videos like the ones you've shown. They make a lot of assumptions that are based on circular reasoning, and they always imply that they've got this perfect phylogenetic tree, when in fact, convergent evolution is not rare. Incomplete lineage sorting exists. Mosaic evolution exists, okay, where they look at something like the platypus in the same way that I was looking at the fencing pliers or the amphibious assault vehicle. Where do we classify this? I don't know. The amphibious assault vehicle probably doesn't care where we classify it in the same way the platypus doesn't care. But these incongruencies, these confusions, these contradictions to the phylogenetic tree, they exist. And that's the problem, is it's not as neat and nested as the evolutionists oftentimes make it out to sound like in these videos. What are your thoughts on that? Do you believe that convergent evolution, incomplete lineage sorting, and these other inconsistencies, do you think that poses a problem to evolutionary theory overall?
Probably not. It's that we have DNA, so that's how we can compare life from other life. And you don't have DNA in man-made objects. I mean, unless you put DNA into it, of course. They made a 3D printer, I think, that prints plastic in the DNA or something. And they can actually reproduce itself or something.
When it comes to hierarchies when it comes to hierarchies in computer programs, DNA code, well, there's an underlying information code to these programs. Okay, it's essentially a 2-letter code, but that is still a code, and yet you still see programs, subprograms, functions, sub-functions. You can still see hierarchies even within these computer programs in the same way that you see it within modes of transportation. Modes of transportation are essentially based on a blueprint, right, that somebody came up with. And that's why you'll see a lot of these blueprints for these different modes of transportation are very, very similar in the early stages of development and manufacturing. But it's not until the final stages that you see the major differences, which is exactly what we see in the biological world, especially when it comes to the embryology. We see a lot of similarities in the early stages. But this is what I'll say. I think this is a fatal blow to what you're implying here when it comes to convergent evolution, in the fact that what we see in terms of convergent evolution is far better explained through epigenetics. Okay, so there's paper after paper, and I got one here that talks about how epigenetic variation, okay, what this is it's an extra layer of genetic complexity and information. Okay, it's above and beyond the genome, where we've got all these switches, okay, in our genomes that are just waiting for environmental stimuli to be turned on or to be turned off. That's why we see rapid adaptation right now that evolutionists have been shocked to find, because evolutionary process dictates that these changes arise slowly over time, right? But no, we're seeing adaptation, let's say in fish. Okay, you see due to predation, these fish can adapt and change their morphology within 3 days because it's built in. This is built-in genetic capacity to evolve based on the environment. Even here, there's a recent paper, okay? Epigenetic variation may contribute to the phenotypic diversity of Darwin's finch. Even Darwin's finches, the morphology that we see, they're suggesting could be done based on epigenetics. Here, recent work suggests that heritable modifications in gene expression and function, independent of changes in DNA sequence, may also be involved in the evolution of phenotype. So here's the point that I'm trying to make. What we see in convergent evolution is better explained from a design perspective, because these changes and the independent adaptations that we see in the biological world can better be explained through forward thinking. That's why we see forward thinking mechanisms in the genome, which points to what? A forward thinker. Okay, this is designed variation. This is built in capacity, okay, to adapt based on the environment. So how, to you, take your time, because I've been going on for a while. What are your thoughts on all of this when it comes to epigenetics, forward thinking, okay, the built-in capacity for change and for modification? Here's the thing, those genes and that information was already there, though. You've got genes being turned on, okay, via the environment. Nothing's been added. It's already there, right? It's been front-loaded, essentially. So this points us back to a designer, okay? Anybody with 2 eyes and half a brain would conclude a designer out of this, okay? This is just obvious. But to you, obviously, you hold to naturalism and evolutionary theory, I believe, as an explanation for origins. So how do you get around this evidence for design, I guess, would be my point. Go ahead.
Yes, nature is designer. Doesn't mean it's intelligent. And these things can happen naturally. You're just not looking at it maybe the right way. You don't know all the things in the past. I mean,
how do you believe they could happen naturally?
Which they?
How do you believe that they could happen naturally, as in the epigenome, which requires forward thinking. Okay, it's like a spare tire. Somebody designs a car with a spare tire. They are using forward thinking, as in, hey, listen, one of these tires may get a flat due to whatever, due to an environmental situation or condition that was unexpected in the moment. You're driving down the road and then boom, you get a flat tire. So they, through forward thinking, they put a jack in the back seat to help. They got a spare tire, so you get a flat tire. Thank God for that tire was there, okay? Because now we can change it out and we're good to go. So that required forward thinking. Natural selection sees the short term. How does the organism survive till tomorrow? Okay, it doesn't worry about getting cancer 30, 50, 60 years from now. How do I survive till tomorrow? It doesn't see the long term. So my point is, how does natural selection and mutations, which essentially see the short term, build that and design that which requires long term?
It's the ones that had those modifications.
Right.
It didn't have to be. It's the one that survived, that had been modified from the DNA and stuff messing up, or retroviruses. Yeah. Do you know anything about endogenous retroviruses?
Yeah, we can move on to endogenous retrovirus, but I want to point out that your argument or your explanation for the forward thinking mechanisms in the genome, you are giving the environment, you are giving mutations, natural selection, these modifications, okay? You're giving them a mind when they don't have a mind. Epigenetics, the point is it's not random, and these epigenetic changes occur in response to the environment, okay? Not to mention that they occur through incredibly complex mechanisms that I pointed out are already there in order to generate those changes. This is forward thinking. Now, here's the thing. The evolutionists, the atheists, they can reject all this evidence for a forward thinker all they want. But it's not scientific. It's not logical. It's not plausible. It's not probable, as John Maddox would say. Okay? And this is why we get a lot of just so stories. Well, maybe the modifications or survival of the fittest, or it just happened that way, or, we're going to give natural selection a mind. So, and it's okay that you believe these things, but it's my position that it's not science. But you evolutionists want to go around parroting these explanations, these stories, these fairy tales as science. It's not science, though, TopDawg. It's not. I'm sorry. I mean, you guys are just going to have to admit it eventually.
We're not given a mind where if we did, everything would survive, wouldn't it? But it's the ones that did survive after all the other ones died out because of those things that have changed to make it survive. That they kept on reproducing before it died. So the organism.
Right. So, at this point, yeah. Okay. So,
problem.
Okay. So at this point, why don't we? Okay. So you're endogenous retroviruses. Then we'll move to that one because you brought that up. So your next line of evidence, I guess, aside from hierarchies, cladistics, taxonomy, and the underlying genetics, your next line of evidence, I guess, it sounds like, that is most convincing to you is endogenous retroviruses. Did you want to take a few moments to explain why you believe the existence of ERVs is best explained by evolution and universal common ancestry?
They are usually random, and so that makes it really hard to, if our DNA has these ERVs in that exact same spot in all the organism isn't them. I mean, there's multiple ERVs in us, of course, like 8% or something. So with those further back, more places where the ERVs are the same spot where they get into their DNA in the past. So it'd be more common ancestry from that, because it's too much DNA with the randomness to be that pinpoint for the viruses to be in the same spot.
So essentially, you're assuming that these ERVs were integrated into the genomes millions and millions of years ago through ancient viral infections, is what you're saying?
Well, yeah, and it's consistently happening all the time, I think, too. It's not just happened in the past, but when it did, it's the ones that after they had babies with that virus split off to make other species or whatever, and then now they both are different creatures. I mean, DNA-wise, they have more DNA difference or something, other parts, but the retrovirus is in the same spot.
Okay, so you're assuming that these endogenous retroviruses then, just so I understand your argument, you're saying, and I'm going to say you're assuming, that they are the remnants of ancient invasions of RNA viruses. Okay, and since we see those same viral-like genetic sequences in the same genomic positions as, say, humans, as in chimpanzees and the other great apes, you're saying that essentially we would have had to inherit that viral-like DNA from a past common ancestor who got the virus. It went through the germ cell lines, obviously, to be passed on, and therefore chimpanzees and humans are related. Is that kind of the argument?
It's one of the reasons.
And what's the percentage of the human genome you said that consists of these transposable elements?
It was 8%, I said. I think in the video I just saw. Or the video is going to show you.
I believe
if you wanted to.
I believe what they do is they subdivide the transposable elements into a couple different groups, because you've got DNA transposons, which is about 3% of the genome. But then you have these retro-like elements, which is like 42, 43% of the genome. So overall, you're looking at about 45 to 46% of the genome consists of these retrotransposons. Now, here's where I want to go. Unless you want to add to that argument, let's, for the audience sake, let's first talk about viruses in general. Like, TopDawg, what do you know? What do you understand about viruses? Do you think viruses are overall harmful and bad to living organisms? Do you think they're overall good? What are your general thoughts on viruses?
There's no black or white with it. It's since we wouldn't survive without those changes in the way we are. It's hard to say. And then we know the viruses are damaging our immune system or DNA and whatever in bad ways too, of course. So,
right, so I'm sorry. Keep going.
So it's how they can't be black or white. It's just DNA molecules and stuff, and then it gets replicated and whatever. But sometimes it doesn't work, and like the retroviruses and stuff, or the endogenous ones.
So good points. Good points. Good thoughts. So there is much literature telling us we know that most viruses are actually beneficial to living organisms, beneficial to ecosystems. Okay, the bacteria in our bodies, for example, to go from viruses to bacteria, they are beneficial. That's why people take probiotics. They'll oftentimes recommend after a round of antibiotics, take some probiotics. You want that good bacteria, okay? It's kind of like this. E. coli is good in the gut, not so good in the blood, okay? But it actually turns out that we have more viruses in our bodies, in and on our bodies, than we do bacteria, okay? And we have a ton of bacteria in our bodies. And what the viruses are actually doing, they're controlling the number of bacteria in our gut, and they're also controlling the number of species of bacteria. This is all about function in terms of regulation, as in the viruses are regulating the number of bacteria. So my point is, without viruses and without bacteria, there would be an imbalance in our bodies. There'd be an imbalance in the ecosystem. Okay, you would not want to live in a world without viruses or a world without bacteria. They're needed. Okay, now I want to point out, based on this knowledge about viruses, okay, the viruses that look like ancient viral infections like ERVs, they're actually tightly regulated into the genomes of living organisms, okay? And they turn out to be highly essential and highly functional. My point is, the evidence suggests that these viral-like sequences, like endogenous retroviruses, they were actually created this way by God. They were designed, created to be beneficial to us, beneficial to the environment and ecosystems. Now, when it comes to these functions, okay, I'm going to screen share real quick, and then I'm going to yield for a bit for you. Okay, when it comes to these viruses, actually, I got a ton of slides here, so let me find them first. But as I'm finding them, okay, a virus needs a host to replicate, okay, as you know. So therefore, what came first, the host or the virus? Did the virus predate the host? Because if it needs the host to replicate, what came first, TopDawg?
I'm not a scientist, so I don't know. But they were working on it, aren't they?
But think about it. If the virus, the viral-like element, needs the host genome to replicate, then could the RNA virus or the viral-like sequences, like ERVs that we're talking about, could they have predated the host genome?
There's certain RNAs that can reproduce themselves, I think I heard.
So the point is, these viral-like sequences, here's the question, okay? And I've had many debates on this, including with PhDs, conspiracy cats. The question is, are these really the ancient remnants of viral infections, or are they created units of DNA function? Well, the evidence suggests, based on a number of reasons, based on the fact that viruses in general are healthy, beneficial, okay? RNA viruses need the host genome to replicate. Therefore, the host would have predated a lot of these transposons. They can jump around the genome, inducing variation, inducing adaptation, okay? So us as creationists, we would call them variation-inducing genetic elements. They're there for a reason. They help with adaptation. They help produce variation. They're beneficial. There's paper upon paper. None of this predicted. Retroviral promoters in the human genome. The data suggests that ERVs may regulate human transcription on a large scale. You get pseudoscience pushers like Erica or Dan, the pseudoscience man, who say things like, well, it's just a couple ERVs or a couple viral-like sequences that were co-opted. Just a couple, you know, which is just such a lie. Literally says ERVs may regulate human transcription on a large scale. Look at this. Endogenous non-retroviral RNA virus elements, evidence of a novel type of antiviral immunity. And it's just function after function. Activity in human tissues. Okay, and those are just a few papers. I mean, if I keep going down here. So here's the point. This whole idea that, so now we get to the similarities, okay? Now we get to your main argument about the nested hierarchical patterns that we see in terms of these retroviral-like sequences. Well, if they're created units of DNA function, as we are proposing, TopDawg, well then obviously by definition, would not the human and the chimpanzee share more of these than a human and an old world monkey or a human and a fish? Okay, obviously, if they're created units of DNA function in the same way we share more genetics with the chimp, then we're obviously going to share more viral-like sequences with them, especially if they were created, especially if they're beneficial, if they're functional, if they're essential to regulation. Okay, they're beneficial in determining cell types. I mean, I can go on and on and on. So I know I just talked a lot there, but you brought up ERVs, which is a good discussion to be had. Okay, obviously I got a ton of slides here, so I got other papers too. But yeah, what are your thoughts on that? Because here's what I wanted to show you. So a lot of these retrotransposons, okay, are even beneficial and helpful in transcription, epigenetics, beneficial in the brain. So if ERVs, shared ERVs, is the best evidence that the evolutionists have, and in my opinion, evolution's dead. Because the old thoughts about ERVs have been completely overturned, completely dismantled. What most people think about viruses is not actually true. Viruses, for the most part, are health. A lot of these parasites, a lot of these bad bacteria that cause disease, they're actually highly degenerated forms of the good bacteria. That's what mutations do, genetic entropy. So, yeah, give some thoughts. I'm going to mute and address anything you want to, and because we've been going over an hour here. So go ahead there, TopDawg.
We were looking at modern life. So it's hard to know what the original life is like, too. It could be completely different than what we understand.
John said, oh, I'm sorry, go ahead.
I forgot already. Sorry.
Okay, so before we end it here, so you've got nested hierarchies, taxonomy, cladistics. Transitional forms are extremely rare. The few mosaics that we find are consistent with our model because we see it in the design world. Tiktaalic's a complete failure, okay? Because they've found, after the discovery of Tiktaalik, they found tetrapod foot tracks in Poland that predate Tiktaalik by 20 million years. Oops.
Yeah, there could have been many times that life found land. It didn't have to be that one.
Okay, so then why is this just not another creature? Another design creature like we see today in terms of the platypus or lobe-finned fish? Because there's no series of progression. You got tetrapods existing apparently 20 million years before Tiktaalik. So why are we to believe then that this is a transition when it's just not another type of creature designed like the rest of the biological world? Why is this evidence for evolution is my point.
I don't know much about it, really, other than that we know that life is not black and white, and how we think of how land and stuff, like, and all that. So you gotta think of all the different life forms that, like crocodiles and stuff, they don't just live in the water. They live on land too. Or they walk on and stuff. But they're like really older than dinosaurs too, and they're related to birds too. So it's pretty weird.
So these are just
works.
These are all just assertions, or you're purporting this, purporting that, with no real lines of evidence. For example, crocodiles. Okay, you're saying crocodiles and banana plants are related through common ancestry. Why? Well, so far we've heard nested hierarchies. We've heard from that video a couple transitional forms that have been completely overturned. We've heard ERVs. Okay, so you brought up all these numbers of lines of evidence. But tell me this. That video was assuming thousands and thousands and thousands of generations, okay? So why? And Speed of Sound, he's in the chat. He's failed miserably at this. Speed of Sound should just retire, in my opinion, because, I mean, the guy's response videos, they're comedy shows. He goes through 30 seconds of a video, thinks he's addressing something. It's in one ear and out the other with him. So I'm going to go find it. Why do we then only see 200 to 300 generations worth of time in mitochondrial DNA, in Y chromosome DNA? For example, here's a Y chromosome tree. Here's a mitochondrial DNA tree. Now, I know this is technical. It's phylogenetic, so you don't need to really understand it. Just know that these lines, these branches all represent DNA differences. DNA differences, the result of mutations. There is only a few mutations here, okay? So I'm actually going to teach Speed of Sound something here too, and Dr. Dan, because they're both a little bit you know, since they're my atheist friends, I'll just say, sorry about my friends. They're a little slow. Okay, here's the thing. The mutation rate is fast in Y chromosome and mitochondrial DNA. It's about 0.5 per generation in the mitochondrial DNA. Do you know, TopDawg, how many mutations you and I, do you know on average how many mutations or differences we are removed from the Eve sequence that we have?
I don't think I care about the extreme details that much. I'm not a scientist,
that's okay.
so I don't need to think
And
about
that's okay. That's okay. I've had discussions with Dodgeball Dan. He knows. So on average, it's only about 22 mutations that any of us are removed. We're only different by the Eve consensus sequence by about 22 mutations. The maximum difference. Okay, so that's your timer. I'll end it with this, TopDawg. Okay, on average, it's about 22 differences. The max is 100. If our mutation rate is 0.5 per generation, okay, do the math. How long does it take to acquire 22 differences? Not very long, a minimal amount of generations. Now, your critics like Speed of Sound and Deceitful Dan, they want to say, show me the numbers, because we got to account for purifying selection, substitution rates. Yes. Guess what? If it only takes a few generations to accumulate such a few amount of mutations, when the mutation rate is about 0.5 per generation in the mitochondrial DNA and about 1 per generation in the Y chromosome, guess what? We have a ton of generations to now account for massive amounts of purifying selection. Okay, there's only a few substitution rates overall. We have a couple bottlenecks according to our model. Guess what? The numbers fit perfectly with our model, and it is impossible for evolutionary PhD scientists like Dodgeball Dan to ever come up with a story that's believable enough to say that this is a reflection of a couple 100,000 years, universal ancestry destroyed simply by comparing humans to chimpanzees. We don't even have to say, oh, show me evidence why humans and banana plants are not related or related. I mean, no, we can just go closest to home. A lot of people, I guess, a lot of evolutionists say, oh, these creationists, they always want to talk about humans and pine trees. Show us the evidence for that. No, show me the evidence for humans and chips. I'll go as close to home as possible. And that is what destroys universal common ancestry. And even the best of the best, which are not the best, have no answer. So anyways, I know I went on a diatribe there. And since you're the guest, as I always do, TopDawg, to be fair, I'm going to mute myself. You get the last words. You say what you want. Say anything you need, anything you feel like maybe you didn't get a chance to say, and I won't even respond. You get the last words here. What would you like my audience to get, I guess, from your presentation? Go ahead, TopDawg.
Could you be misunderstanding what the scientists that actually study this subject, that actually work on finding out and observe all these and write them down? And that's what we get. So if you don't understand, doesn't mean that a god did or an intelligent designer did it. Because humans are not perfect anyways, and so we're not going to know everything. And it doesn't mean we know, maybe never know it, you know. You never know. We just know what we know now from the observations. So, and that's what's written down in science. So there's no presupposition. There's no agenda, hidden agendas or anything, probably. It's just actually what we observe. And then that's what the scientists have written down. So that's what we got.
All right. Well, TopDawg, I got to say, I appreciate you giving us your time for this important discussion. I think these types of discussions are profitable and important. Just because we disagree on these scientific issues doesn't mean we can't come together and have a cordial discussion. Just like I had a few days ago with Rational Empiricist, Luca, a couple weeks before that. So these are important. Let's keep doing them. Thank you for being here. I appreciate it. I appreciate you bringing the video. And we're going to get this after show started because we're going to celebrate our 3,000 subscriber party because logical, plausible, probable. He's not somebody you want to, I mean, you don't want to make this guy mad. You know, he is, I'm just glad he's on my side. I ain't going to mess with him. And, you know, he's got some cap locks going on. So, John, we're going to get this party started, brother. So let's do it. We got it. We got a new background here. Okay, so right here, guys, is me rocking the Pond Scum to People shirt. Pond Scum to People Evolution shirt. So I'm telling you, pick up those shirts, rock them to the gym, and trigger the heck out of those meathead evolutionists that are on the bench press. And you never know, maybe you can throw in a brief creation versus evolution debate in between sets. All right, guys. We're going to start the after show. Good times. Thank you, Top Dog. SFT is out.
Yep.